Okay, so we already did memory day 1 and day 2. Those grades are already in your file. For the record, what I'm going to do, because we're kind of out of time, I'm going to went through the CPU blogs. Some of them are spot on. Don't look at your grade. The grade that's in there right now is the grade that your compadres gave you, which is not the grade that you're going to get. Because what I did originally is I put them all in. I used the Excel spreadsheet to average the grades, and then I read them. And some people have things that are totally wrong in their blog. Incorrect information. For instance, does a AMD processor use hyperthreading? No, there's no such thing on AMD, right? Hyperthreading is an Intel only thing. Does that mean if Intel says it's 4 cores, that it has hyperthreading? No. That has no relevance. So one person said their computer had 2 cores hyperthreaded, so it said it was 4. When really it was just 4 cores with no hyperthreading at all. So some of the things, and I'm just pointing at the one person that I remember it well enough off the top of my head.
Anything bad about mine?
Plus, we had a tendency to not capitalize, the first word in a sentence, and companies like Intel and AMD, which is A, capital M, capital D. It's an acronym, right? So that is, I'm going to put the grade in there, and then you have the ability to edit that and email me that you've made some changes. So we've already done Memory Day 1, we've done Memory Day 2. Memory Day 3, I really used to be 3 and no 4. I moved some stuff down because I want to talk about how much RAM we need. I want to finish the discussion we had the other day, which is related to how much RAM we need. I want to talk about how to find laptop memory or any memory for a PC, and then we're going to go and test memory. Okay, so we're not going to do these other reading articles, and honestly, I may just assign those to you to do on your own. Because really you need to understand these and read those before we go on to the project. These blended learning activities right here are optional, not required at this point unless you do poorly on your tests and you need to do them in order to do the test retake. So those are not required items, but you can certainly do them to see how you're doing before you take the test, which is after the project. So first thing I want to do is I want to continue the discussion that I started to have last class when I was rudely interrupted by the bell and the class ended, okay? So what I was talking about is how the CPU uses cache and I had my paper out here, so I'm gonna get back to my demonstration here, and Ian, of course, is gonna be the person I demonstrate with. So you only have 2 gig of RAM, okay? So that's all you've got on, you're the processor, by the way, so you've got 2 gig of RAM, and that's all you've got.
That's embarrassing.
All right. Each gig is, in this example, is represented by a piece of paper, okay? So over here, way over here, which, by the way, takes really a long time for me to get to, is the hard drive that these pieces of paper that I'm setting out represent just available space on the hard drive to save stuff, okay? So Ian's got the memory, Ian's the CPU, he's got so much cache available to him, but when he runs a big program, we know that the most cache, the biggest ones, are in the megabyte range. They're never in the gigabyte range, right? So a really good cache might have 20 meg of cache, and Word takes a half a gig just to open, okay? So when, let me use my, need a pencil for this demonstration.
It's like a reading computer.
We'll use this pen. Okay, so Ian has had Word open by, what do we got now? We got a new case with a keyboard and stuff.
Yeah,
So Ian has had Word opened by Brandon on his PC. Okay, and so 1/4 of Ian's memory just went away because he had to open up Word. Okay, and then while he was working on it, he was also working on a PowerPoint. Okay, so he opened up a PowerPoint and he opened up the internet. And Ian is quickly running out of memory. Okay? So what he's doing as programs open, what happens is programs open, then parts of that memory get allocated to programs. Okay? So Ian's opened a program and this much got used for one. And then he opened up another program and this is a very simplistic illustration, just so you know. Okay? And then he opened up another program and it started using this. Okay? And now Ian's running out. Are there any other programs running right now on Ian that we know of on a PC? What other things are running despite of those? Okay, no. Seriously though, what other programs are running that we know are running all the time?
Okay. The OS.
The OS, right? The operating system is taking up a big chunk of RAM. Okay, so I don't even have that on the illustration here. What else is always running on your PC? 100% of the time.
It's antivirus software.
Okay, right. We have antivirus software is running 100% of the time. And if I wanted to see all the things that are running on my computer, I can open up Task Manager. And if I open up my Task Manager, which I'm hoping will be on this screen, but of course it just opened on the other screen. I wonder if I can just move it. Let's see. I haven't tried to do that. It's the downside of my, no. So it's open, but it's open over there, so I can run over here and bring it over here. So these are all the things that are open already, despite the things that I think I'm using, okay? Despite those things, I've got Firefox open with 2 browser windows. I've got this recording software, which you wouldn't have. I've got Remote Desktop open. I got my Smart open. I got Task Manager open. And I have 59 other things open right now, running on my PC. All these other things are running in the background of my PC. And you see Chrome's taking up a ton of RAM. And we can see on here what the percentage of CPU, what the percent of memory. So right now, memory, this recorder is taking up most of my memory, but any time I can see how much the memory is taken up. It's taken up 289 right there, okay? So those things are always open all the time, but what happens when Ian runs out of room on his pieces of paper? It doesn't lock up. It's got another option, okay? And the other option is your hard drive. And on your hard drive, there's a file called a swap file. And what the memory controller does while it's running is whenever it needs to, whenever it's out of memory, it goes and says, hey, I'm going to write this over on the hard drive for a minute. I'll leave you over there. Here, CPU, you've got more space. Oh, wait, you need more space? I'll write this over here too, and then I'll give you more space so it can get back to work. So the CPU keeps writing here, and the memory controller keeps swapping out over here. Oh, you needed Chrome again. Hold on, I'll give you Chrome. There you go. And they keep swapping back and forth between the swap file and its actual memory. So the more memory we have, the less it goes to the hard drive. The faster hard drive we have, the quicker it can do the swap back and forth. So it's a catch-22 when we're talking about systems. We can go low on, your guys are low on memory, but we have solid-state drives, which are memory, right? Mm-hmm. So we can get away with 2 gig of RAM on yours because we paired it with the solid-state drive. That yes, it's slower than memory, without question, but it's 10 times faster than the hard drive. You take that same computer and put a hard drive in it, and all of a sudden you're like, why is this computer so slow? And it's not slow just because the programs load off the hard drive slow. It's slow because it's doing this crap back and forth between the hard drive and the memory, swapping it back and forth, pretending that this is memory too. It pretends that the swap file is memory. The CPU is still only talking to this. The memory controller is going back and forth. Okay, the whole time, whenever he needs it. So Ian doesn't run out of RAM. He just keeps, well, he can still run out of RAM. Because if any one process that's actually running at any one time needs more than the 2 gig he's got, it still the CPU can only talk to that 2 gig. So if it needs it all at once, like on intensive video software or an image file, just had happen at my house this morning. It's editing a large image file. And I hadn't restarted my computer, which is another conversation we're going to have in a second too, and it ran out of memory, and the program said out of memory and locked up. Because even though I got a huge swap file and I got a huge amount of hard drive space available, it still has to, the CPU only sees this. no matter what we have over here. This is just so the memory controller can fake out the CPU, put it aside for a minute so it has some room to do calculations, and then it'll move it back there when it needs to. Okay? So the swap file is fake memory. And if you run out of room for a swap file, because this gets allocated as a backup thing. Okay? So if your hard drive is full, completely full, and all it has is this, your computer would be hosed. You're like, why is my computer so slow all of a sudden? Because all of a sudden it runs out of room for the swap file? Because it's not like it's allocated normally. Okay, you can force it to have allocated space. So a lot of people don't know about that, and that's why more memory is better, because it'll go to the hard drive less, especially on a system with the spinny drive. The more memory you have, the less it goes to the hard drive, the less it goes to the hard drive, the faster everything runs.
So wait, there's solid state drives in the Mac lab?
Yeah, they all have solid
Really?
state drives.
Yeah, that sucks.
Why?
I mean, they're just solid state drives. I mean, that's kind of putting it up with a bunch of kids that punch their computers all day.
Yeah, why do we put solid state drives? Two reasons. Number one, it makes them run faster. Number two, they'll last longer. There's more reasons than that. Number three, uses less battery power. There's no motor spinning anything. So it doesn't. The hard drive is the one thing that's running all the time with a motor that kills your laptop battery. You put in a solid state drive and immediately extends it. And when we didn't have solid state drives, there's always some goomba who thinks a laptop is intended to be moved while it's running, which it is not. It is a portable PC that's intended to be moved in the off position. Right now, it doesn't. You can juggle it, and it wouldn't matter. Well, unless you dropped it, right?
Yeah.
But it doesn't hurt anything because there's no spinning and moving parts yet. Good.
Alright, so.
Oh,
what's
no.
Faster? Wait, what?
What?
Okay.
This computer's about to explode.
I want to see if my mic was. What was your question? What?
So, mine is using like 70+% memory. So how much faster would yours be using only 20 than mine?
Well, right, it is faster because not only is the processor faster, but the processor doesn't have to go to the hard drive, which is an example of why yours would really suck with this spinny drive.
Awesome.
Okay, because you run out of memory all the time, but you don't because you got a cache drive and it goes ding 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 back and forth to an SSD,
So the
which
more
is what
memory-
makes those run faster than they're supposed to.
So the more memory that you have open, like mine was down to 20%, it skips that step of.
Yeah, it doesn't ever have to go to the swap file.
Alright.
Okay. Now there's a setting on your computer, and I'm going to show you that while we're there, and it's of
So-
course not going to come up on this
If
one.
you're making like a gamer PC, you just want to have a ton of RAM.
Yes, you would want more RAM
Like,
because it would run way better if it had more RAM.
so is Christmas actually like stockpile RAM in my PC? That's like
Well, I mean, there's a limit, right?
Yeah.
It's only going to use so much. If you've got 16 gig of RAM,
yeah,
you're probably fine. That's kind of the sweet spot.
yeah.
When I took mine from 16 to 24 at home, I saw zero difference. Zero difference. Why does this have 24? Because it's tri-channel,
Okay.
and I have to put it in sets of 3, so I could either have 12 or 24 to use the tri-channel. So mine has 24. Okay, if it had dual channel, I would only have 16 in it. But it doesn't. I have to put 3 in to make use of it. Okay, so there is some settings. Okay, so I'm at the Windows property, and I'm going to go to Advanced System Settings. And of course, it's on the other screen. So why don't I just sit over here while I'm explaining it? Since, dang it. If I make, you know what I should do? I should make this one the primary, and then all those things would just open over there. Okay, so when I go to the Advanced System Settings, I see this one called Performance up top. When I go to the settings on performance, one of the advanced things I can do is look at the virtual memory. And that swap file that I'm talking about is called virtual memory. It's not real memory, okay? It's that paging or swap file, and you can set the size of that file. Now, by default, I have mine set really small, okay? I'm gonna hit change and it's gonna open the other window. Thought it would stay here. I did it on the same one. No, it didn't open on any window. Why didn't it open? There we go. Okay. So when I go there to that, I can define what it is. Now this is not normal. Okay? The normal that it says is system managed. If I go to system managed file and I hit set, what it does is it takes and says 2.5 times the amount of RAM that's in your system. Okay, so if I go, I'm going to go ahead and hit set. Now it's a system managed. I'm going to say okay, and I kind of come back here, and that's really weird because it should have said way bigger than that. But here's the downside of system managed file. It will expand and contract it as needed whenever it needs it. Okay, so the minimum size, they're going to start out with 16 meg. It's going to say, we'll start out real small. And then when it needs it, it goes bigger, and then it goes smaller, and then it goes bigger, and then it goes smaller. And that really, really stinks for your hard drive. Because what happens on your hard drive, and we'll learn about defragmentation and fragmentation later, but if the whole time that swap file starts here and now it's expanding, well, on the hard drive it doesn't get to use that, it just makes another file down here. And then it makes another swap file over here, and these are kind of connected like that, and then it makes one up over here, and now it's connected like that. They're not together. So if you let the system manage your swap file, it gets bigger, it gets smaller, it gets bigger, it's smaller, it's never together, and it's harder for it to write to it. But if I do like I just had and said, you know what, I'm going to set the custom size, I'm going to make it 2, which is really small, I'm going to make it 4. If I do that, then I'm just saying, hey, there's 4 gig here, it's yours, and it's staying right here. And now when it makes that file, it goes, here's your file, and it's all together, and it reads and writes in one spot. Okay? So does that make sense what I'm trying to tell you? That this, which is the Windows default, sucks. It's better if you go and just say, okay, how much RAM do I have? How much swap file do I need? Now I have 24 gig of RAM. I really could put a 0 on there, and it would most likely have no effect whatsoever on my system, because with 24 gig of RAM, I shouldn't be going to a swap file ever. With 2 gig of RAM, I would set 4 gig as my swap file, okay, so that it's got 4 gig set aside all the time. It never loses, because when I set this, then on my hard drive, let's say this is my whole hard drive, it goes and says, this is swap file, do not touch, and it's always there. It also tells you there's less space free on your drive. So if we were going to go to our hard drive, that's not what I wanted to do at all. Why is that even up? I don't need that right now. If I was to go to my hard drive, and of course it's on the other computer probably. See if I got any of them on this one. There we go. Okay, we'll go to this one. If I was to go to my hard drive and look at my C drive, and 4 gig of that is being taken by my swap file right now. I just told it to do that. Okay, and if I change it to 0, all of a sudden it would say there's 124 gig free, because it allocates that as a file like any other file. Okay, so you have to have room for the swap file that you specify. But if you do, and if you say the swap file must be this big, it will make your computer run faster, it'll make your hard drive cleaner, okay? And usually 2.5 times your RAM is the sweet spot, unless you've got a ton of RAM, and then I'm not gonna waste my hard drive on a swap file that's never gonna be used. So, did I explain what a swap file is? Okay, it's hard drive virtual memory. It's called also a paging file. So right now, this is what it's recommending, which is really low, probably because I have so much memory it's not recommending that much. In fact, we could look at one of your guys and see what it recommends. But I always use custom. I could say none. You could also put it on another drive if I didn't want it to use my SSD, which would be crazy. I, of course, want it to be on my SSD. But I could put it on one of these other drives, too. I could say, I want it to be over here on this drive, and there's none there.
You have multiple?
And there's none. What?
Multiple paging files on each?
Yes, you can.
Oh.
You could. I don't know why you would. That seems like a bad technique. But it will let you do it. Yes, Cody.
Okay. So I need your administration password and to get to where you're at. And also, why do you always put 48 at the end of any gigabyte?
Because it's always in fours, right? Like so, when you start out, it's 8, and 16, and 24, then 48. So really, 4 gigabytes is 4048. 1 gigabyte is 1012. 2 is 20, 24. It doesn't matter. It doesn't matter. I would have used whatever I said, but I make it a round gig number. Because I'm writing in megs, right? That's a meg number, not a gig
Why would
number.
1 be 1, 0, 12?
Because it is.
Okay.
Okay, so here, let me do that.
I don't understand. Do you go up by 12s by 4s? Like 1 to
It goes
go
up by
2,
4s.
24?
Yes, yes. It all goes up by 4s. It's all multiples of 2s and 4s. And it won't let me do that. Oh, so once. Are you trying to go to the same page?
Yeah. I clicked on the system stuff and it was like, when you need all this.
Let's see if it'll let us get to it. Okay, so let's see about on here. We'll go to performance settings, advanced, and change the paging file.
760 something.
So right now it's set. These are set to automatic. Okay. So it's saying it's using 768. It's recommending basically half of your RAM. It's not doing a normal calculation, but so right now it's using 768. Now, does it matter on yours, which is why it's not set?
I think so.
Yep.
On a SSD drive, it's not like data stays together anyways. It writes wherever it hasn't written a lot to anyway.
So it doesn't
Because it's
matter.
just memory. It doesn't matter on that.
Man,
But if yours
I'm
is
not
a spinny
speaking
drive,
so-
it definitely does matter. You can't defragment an SSD.
So if I change this, it's not going to speed it up.
No, it's not going to change it at all. Not going to change it at all. In fact, it might, in fact,
Slow it down.
slow down because you're using more than you need to on a solid state. Because this is really what I'm talking about. That I'm talking about a spinny drive that gets fragmented. SSDs.
Could you totally prank someone by changing their?
If you change this to 0
Yeah.
to none
Would it,
on a system that needed it, like ours do, it would still work. It would just slow down, and then every once in a while, Cody'd get an out of memory error. You're like, why is this one running out of memory all the time? Because it's telling Cody, well, I might need another gig of RAM, so I'm going to use as much as a gig.
Alright, well, since you put your administration password in here, every time I click on that, it still asks for it, right?
Yeah.
Okay, so I don't have to worry about them doing that to me.
No, you don't have to worry about
when
it.
it says it's out of memory, does it just have to? Stop
Usually
it?
just freezes either the program or the computer. In my case this morning, it froze the program. I had to go to the task manager,
End it?
and I had to end the task
Oh, I
and
hate
reopen
that.
Paint.
I hate that.
So-
I think
But that's what it was. Okay, so that's the idea of a swap file and how and why we might need more memory. The more memory we have, the less we need the swap file. The less we need the swap file, even with an SSD, the better our system's going to run. Okay, so that was one of the things I wanted to make sure you understood before we talked about, and this is old, I need to update this, how much memory things require. And this is a Windows 32 thing, and I need to really update this. Okay, so it says on here a casual user can get away with 1 to 2 gig. That is not true anymore. Windows 10, if you don't have 2 gig on it, will not even work. 2 gigs the minimum to get Windows 10 to work. It will run out of memory. Okay, I should say this. It will start, and as soon as you open the very first thing, it will be out of memory.
Sounds awesome.
The very first thing. On these thin client computers right here, all they do, there's Windows 10 on these, all they do is open up Remote Desktop and go to the server, and you run everything on the server. Nothing is running on these. If you put Windows 10 on it with one stick, which we tried, it boots up just fine, and as soon as you open a Remote Desktop, it's out of memory and it freezes up. But with 2 gig, it runs just fine. So 2 gig is what we're going to say is the casual user amount of RAM. You have to have at least 2 for it to work at all. That's like I'm saying that, but I'm going to edit this when we're done with class. Frequent user, I'm going to say 4 gig is fine unless you have a 64-bit operating system on it, and then we're looking at 8 gig. If I'm going to have a 64-bit operating system on, I'd really like to have 8 gig of RAM. And then when I get to being a gamer or graphic stuff, I'm really at 16. A gamer sweet spot is 16. Above that, you're really not going to see a difference. My oldest son is a huge gamer. I bumped his up to 32, and it did nothing. He's like, I thought it'd run better. I was like, I was pretty sure it wouldn't, but. And then down here, I'm going to edit this before I really assign it to you, but it talks about how much different systems need, and that's why I need to update this, because really it should say Windows 10 32-bit 2 gig. Windows 10 64-bit will still run with 2 gig, but you're really kind of losing memory by doing that. You should have 4 on there. So that's what this chart is for, and it goes all the way back to when we had Windows XP. You could get by with as little as 512, and then as we moved forward, we needed more and more. So I need to add Windows 10 on this chart and put the Windows 10 requirements, because Windows 7 really did get away with 2 gig rate and 1 gig fine, but the more applications that you run, the more memory you need, because the OS is using more, the programs are using more today. Oops, clicked on the wrong place. Programs are using more today than they did before. So every time we open something up, which gets us to the next thing, we find that we need a little bit more RAM. Okay, there's one other term in RAM that we need to know. Okay. Windows loses its mind. Okay? When I give Chrome, I'm going to divide them up now, this RAM to use, okay? The CPU opens it up, and it gives this amount of RAM to Chrome. And then and then you're done, and you close Chrome. What should happen is, it's freed up for the next program. What does happen is, Chrome forgets to give it back to you. And now it's gone. And now, as far as the CPU knows, it's only got 1.5 gigs of RAM. And then you close Word, and what's supposed to happen is Word gives the memory back, and now it's free. But what does happen sometimes is Word forgets to close right, and now the CPU's down to 1 gig of RAM.
How do you get that back?
Okay? There's only one way to get it back.
Restart your computer?
Restart your computer.
That is so dumb.
Okay? Which is why 90% of the time when a staff member calls and says, I'm having this problem, blah, 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 the first thing I say, have you restarted your computer? What's that going to do?
Free up memory.
That's exactly what it's going to do. Okay? All that memory is dynamic. We know that. It's written to all the time. Okay? And it's allocated to specific tasks and programs and applications all the time. All the time, things are opening and closing you don't even know about in the background, especially if you get a virus or malware going on. And those aren't written to make sure you get your memory back. Okay? So if when you close an application, that memory is not freed up and given back to the CPU correctly, it lost that memory. And the only way to get it back is a reboot. A shutdown, restart will do it every time. Now, Windows 10 does not really shut down when it shuts down.
How do you prevent that from happening?
It doesn't shut down like Windows 7, Windows 8 used to. Okay? You have to do a shutdown and then repower it on. If you do a restart, it doesn't always actually free up the RAM. So with Windows 10, sometimes I'll say, shut down your computer. Is it off? Is the power light out? Yes. Okay, turn on your computer. And it will get that memory back. Okay? Sometimes. Most of the time a restart solves all the problems. And that's why, because it's lost its mind. And it needs all that memory freed up again, so the CPU is like, okay, I got 2 gig of RAM and I'm good to go. Happens to students all the time. Because they just slam the lid on their laptop closed. They don't do a regular shutdown, wait for it to end, and then close the thing, which is why most of the time when they come in here and they say, my computer's wet, swap the hard drive. Because they've corrupted the hard drive by continually just closing it and not waiting for it to shut down before they throw it in the bag. Okay? We just changed the power procedures on everything on Tuesday. It may or may not have gotten to your computer yet, but they're set now that if you close the lid, it doesn't hibernate, it shuts down. It should go through the normal shutdown sequence if you close it all the way. And then when you open it and you turn it on, it should act like it's starting up fresh again, if it's got that new power stuff. And that's because we've had other students walk in, they pull out their laptop, and it's burning up because they never shut it down. They do it and put it away. And then we get the flashing 9 thing because they've overheated their CPU, they're overheating or melting the soldering on their motherboard because it cannot cool off inside there if it's left on. It has to be shut down before it's put away, or those are things that are caused by the students. So is it doing normal startup right now?
I shut it off now and turn it back on.
So
Because I haven't done that in a while.
What?
Since you went ahead and said it.
since you mentioned. Okay, so what I wanted to do the rest of the class was to go over and just go through and test memory. Let me see what our timing is. 10:34. We got a half an hour left.
Let's just build a computer from scratch. Just like
Just what?
wires and stuff that we find around. We'll just
Yeah, I don't
we'll
think
build a
that's.
motherboard and
It's
everything.
not necessarily the way it works. So we're through memory, and I wanted to make sure you understand the memory loss thing. Really, next class or before we get to the project, I need you guys to read these 2 articles, which really expand on those. They're kind of more advanced information that you already got, okay? Because you kind of got the basics, and these are more advanced articles, so that when we get to the memory project, you kind of understand memory a little bit better. Yes, Ian.
So when I compile a map for a game, because I do map development, it slows my computer down way down. Should I just like close all of whatever's happening over here, like the internet and YouTube?
Yeah, the more things you have closed, the more memory that's available to that program, the faster that program is going to run. Most likely, you don't have enough RAM free for that compiler to run, so it's going to the swap fire all the time.
Yeah.
And it's running, but it's not all running in native RAM. It's going back and forth the whole time. So the more things you have closed, the more memory. The other thing you could do is, before you're ready to compile, save it, restart your computer, just open up the compiler and run the compiler. And then you know it's got all the resources your computer has available for it, just for that compiler.
Yeah, because I think sometimes it doesn't really work out. My computer kind of freezes up.
And it could just be that. Or it could be maybe you need some more RAM. How much RAM you got?
16 gigs.
Well, then I would restart it before you start the compiler.
Yeah.
What's the internet speed for Trail?
What?
The internet speed for Trail.
You mean how fast can we get it?
Yeah.
The other night we had 980 meg. We have 1 gig. We have a 1 gig connection. But we don't always get it. When we do a speed test, many times you'll see a lot less than that because it's not because we're not connecting to the internet that fast. There's just not that much connection out of here. So when I run, and I go to speedtest.net, when I run this, I may or may not see my real speed because I can't get out of the consortium. There's 30 schools that share all of it together. So we have a gig to our internet provider, but whether or not we get a gig out from them depends on what everybody else is doing. So last night we had 900 something. You can see we got 600 something right now. That's still pretty darn
So
good.
if you're in the red, is that good?
Yeah, it's way past what it would
Right now,
be considered normal.
we got 20, and the one that I'm going to set up is...
So at home I can get 30 is the most I pay for with Time Warner, which used to be faster than we got here. Before we got our fiber line, we shared 2 T1 lines, and both of them ran at 1.5. So we shared 3 for the whole district, and now we're sharing. What did we get? I don't. Where'd the download go? There we go. 625.
Dude, I want that speed in my house.
That would be awesome. I know, Garrett's
great.
Garrett's like, is there a way we can run a line to my house? I'm like, no, that wouldn't be legal, but. Okay, so I'm going to, let's see, I'm going to go ahead and stop, and we're going to go and do some memory testing, which the lab should be open.